Hello everybody, this is a little video to teach you which are the most common mistakes that I found in the latest midterm, which was May 2022, but also before, during the midterm, so while trying to solve your personal problems, and also during the correction. Okay, let's go through. I will start with a very general problems. The first one is read the instructions. Well, if you have noticed, recently I changed the type of instructions in my exams about smart contract, so I suggested data structure, and I literally do a step-by-step process. I know that this could be frustrating for the people who are already well experienced with programming, and it's also very frustrating for me. But in this way, the people who don't have any experience with programming don't get lost. On the other hand, what I ask you is that you must, and I repeat, must read what I say, especially here, the idea. Because some of you did the assignment pretty well, but didn't read the idea carefully and so twisted some things, especially this specifically here, this 20 minutes. You have not only to read the idea, but also to have a generic idea in your mind of what's going on. It's obvious that you must complain, in this example specifically, within 20 minutes and not later, but on the other hand, the owner who asks for the reimbursement can ask also later and not within. So there are some things which are very obvious if you read the idea and understand it. I suggest reading the idea 2-3 times. You have plenty of times. And then read what I ask you and do what I say. You can, if you are pretty experienced and very good at writing programs, do something else if you believe that it's better than what I ask. But in general, it's easier for you if you stick to exactly what you say. For example, add a payable function book which receives as input a number of weeks. I don't see why you shouldn't add a function which is not payable, which doesn't receive as input a number of weeks, or which receives as input a number and you use it somewhere else in another way. Another thing, it stores the tenant's address and the paid amount. Well, I expect that you store the tenant address and the paid amount. Well, not something else. So read and do. It's pretty easy. I know it's frustrating, but in this way for you it's much easier, especially for those of you who don't have too much experience in writing programs. So now this one is over. The second very general issue is not paying attention to the error messages when compiling. Let me now, how can I increase the font here? Here. I will have here an empty example basically. So now we'll introduce some mistakes, some errors. Okay, let's see, I forget this semicolon, typical error. I compile, and at this point what do? You look, the error is here. There is no error here actually, obviously, there is only a close parenthesis. And you call me. It doesn't compile. Well, it doesn't compile. Please read the error. Many of you, when I tell you, which error, you don't even know that there is an error here below. So you have never noticed that there is an error here. If there is written expected semicolon, guess what could the problem be? Expected semicolon in the line before. Okay, another problem while compiling is that you tend to compile too late. You try to compile as often as you could. So you write a constructor, compile, add a function, compile. Otherwise, it's normal that you find 200,000 mistakes and then you say, well, I cannot even compile it. Okay, it happens also to me if I compile after half an hour. You have to compile every time. It's free. I mean, you don't pay when you compile. You see, I compile, or it's everything correct. Let's see other common mistakes. Let's see, for example, this one, I call it price here. So price here, price here. Okay, and now here I call also this one price, and so here. This is not something you could do because this price gets confused with this price. Let's see, perhaps it is. It tells you only a warning because theoretically it's correct because this price is not this one. Okay, but please don't do it. If you really want to do something similar, add an underscore here so you clearly differentiate between the variable which is price here and the variable here. because and in this case you get only a warning. So another very typical error is this one: address payable a, and here you write, or here a equal message sender. You compile, and there is an error. Well, if there's an error which says type address is not implicitly convertible to expected type address payable, well, if you hit the error, I think it's not extremely self-explanatory, but at least there is an payable inside which should point you in the right direction. That the problem is that there is here a missing payable. So the message here is read the error message, because very often you work like this. You work like this, you don't even care there is something here below. You just stick on this one. Well, but during the lesson you have seen me looking below. Ah, there is an error here. Okay, now it compiles. Can you see? I do a little modification, then compile. Okay, so read error messages. Let's switch to number 3. Number 3 is that some of you, and in this case I have to blame you, cannot use mapping properly. Mapping address, where is it? uint, let's say b. Okay, this must be used in the following way: b of, and here inside you put an address, because address is the key. So let's say message sender, for example, which is an address, or whatever you want, but 0x and the address. Okay, but it must be an address, so typically message sender or owner or whatever, equal, and in this case it must be equal to a uint, for example, n, in this case n by 2, it's a uint, and it's a uint. Okay, so there must be name of the data structure, square brackets, whatever is the key equal to whatever is the value. And you could use this thing in the formulas. You could use this thing in the formulas. So for example, return b of message sender, it will return the uint. It's like in Excel. Let me now open Excel. Excel has disappeared from my Mac. Oh damn. Excel. It's like having a little table in Excel with 2 columns. Just a new function, thank you. Is it so difficult to reach Excel? Okay, so I enlarge it. So with 2 columns, and this address, here uint, and here address, and here uint 45. Address 0x, and here uint, there is an x missing here, uint, so 5, and so on, a little table. Okay, it's basically a database. It's the only data structure we have seen. The only series, there are several other data structures. This is the only one I have seen. In the meantime, you can hear the Mac is almost exploding, so now I have to find a way to lift it. Okay, so please, I would like that you are able to use it, at least this one. I have seen people doing terrible things. I have seen things like this. Doesn't mean meaningless. Or people trying to put here inside something which does not correspond to what is written here. Okay. Not all, in most of the examples we did, the key is the address, but it can be also, for example, uint, and this one be string, or whatever, this one be string, and this one be string as well, depending on what you have in the 2 column, or this one be address, or even a payable address. Okay, depending on what you have in the, on what is the problem, what you have in your data structures. Okay, so this is why did I start saying that I blame you? I blame you because it's the only data structure we did. I expect that you are able to use it properly. Okay, let me remove these things here now. Okay. Equal versus equal. So equal or equal. in general, this equal means assignment and must be used whenever you say something like, here, use it, price equal n. This equal means checking, and you must use it always inside a require or inside an if. Okay, do you understand the difference between this one and this one? Here you are checking whether price is equal to n, and here you are saying that the previous value of price will be overwritten by the current value of n. So if price was 7 and n was 20, after this instruction price is 20 as well. Okay, here instead, if price was 7 and n was 20, after this instruction nothing happens. Simply checks and returns false, and the function reverts. So please clearly understand the difference. This one must always be inside a require or inside an if. Unfortunately, if you write for mistake something like this, okay, the compiler will not give you an error. It will give you a warning, however. Not this one. Okay, apart from this thing here. Okay, this is another type of warning. Let me see, I compile. Can you see it doesn't give me an error? Because in theory this is correct. It just checks whether price is equal to n and doesn't care. So if it is equal to n or if it is not equal to n, doesn't do anything. However, for you, for your level, this double equal must be always inside a require or inside an if. Never alone. So there must be always a require or an if here. Never alone. The payment. Sometimes I ask you to build a function which accepts a payment from the user, so the user pays to the function. So most of the time you write that the function is payable, very well, okay? And most of the times, unfortunately, you write here, uint payment or something like that, okay? And in this way, according to your opinion, the user has paid. No, the user has not paid here. The user has said a number, 7 euros, 7 ether, but didn't actually pay anything. In order for the user to pay, you have to put a require message value larger or equal than the amount to be paid, for example, 20 Wei. Okay? And the require must be on message value, not on payment. Okay. Do you understand the difference between paying somebody and saying a number to somebody? If you write something like this, so without this require, like this, you are only saying to a person that you're telling to the person 20 either, thank you, okay, but you're not paying it. If you instead write something like this, you are forcing the user to pay 20 Wei. If he doesn't pay, the function reverts. So many of you confuse saying a number, a value even, through even called payment. Sometimes you call it fee. If I ask pay a fee, and some of you write like this, and then check something like this, look. Well, okay, very well. The user called the function, doesn't pay anything, but simply says 25, and the require works. No, the require must be on message value. And there is no need to say what you're actually paying. In Solidity, there is no need to say what you're actually paying, because what you're paying is inside message value here. So what you're paying is inside message value. There is no need to say what you want to pay. Do you understand? The students of accounting and finance, I hope, understand the difference between saying that you pay something and actually paying something. It's the difference between a fattura and a payment. Okay, big deal. Usually at least 30 days pass. Okay, so what you pay is message value, not what you say that to have paid written here. Okay, this is a really very typical mistake I've seen many times. So the payment put as function parameter, and then you don't use message value, or you use message value, but that's the reason why do you put the payment as a function parameter. So in Solidity, the person pays without actually saying anything. You don't need to say what you pay because it's already inside message value automatically. Another problem, somehow related, is sometimes I ask you that the user must pay a fee. Let's suppose there is a fee set here, uint public fee, and let's suppose it's already set at 10. Okay, I ask the user to pay a fee. So usually the standard way is this one. In this way, the user is forced to pay a fee, and the fee goes to the smart contract in this way. So the fee arrives to this function, and it's deposited into the smart contract treasury. Finish. Okay. Many of you confuse it and automatically send the fee to the owner. So many of you do something like this then. Owner, suppose there is an owner here, for example. Address payable owner, and here owner equal message. Okay, now it makes sense. And write owner transfer fee. Okay, it could be, but I didn't ask for it. Well, or better, in the examples we had in exam 12, in the 3 examples of exam 12, I did never ask to do something like this. I didn't consider it to be an error, just a little flaw, okay? But, I mean, the fees should stay inside the smart contract if I don't tell you to transfer it immediately to the owner. Well, by the way, there is no reason for the owner to transfer the fees immediately, because in this way, the person who calls the smart contract will pay more fees on Ethereum blockchain, because every time we do an extra transfer. On the other hand, the owner can get everything out later on through an appropriate function. Okay, it's not bad, but there is a big difference between paying to the smart contract, which is simply having the function payable and having a restriction on how much should be paid, otherwise the people will pay 0. And on the other hand, transferring the money from the smart contract to somebody else, in this case the owner of the smart contract, but it could be somebody else. So there is a big difference between the two things. This is paying to smart contract, which is what normally I ask you to do, and this is transferring immediately what has been paid to somebody else. Then we have some issues with numbers. I will write them here, even though it wouldn't compile. Again, some issues with number. I remind you that Solidity does not have decimal numbers. So if you write something like this, number divided by 100, imagine that number is a percentage, let's say 20, meaning 20%. If you write number divided by 100, in Solidity, this is rounded down to 0. Okay? And in particular, if you write something like this, amount by number by 100, this works fine. Let's suppose amount is 1000 and this is 20, no? Suppose amount is 1000 and this is 20. This will be 1000 by 20 divided by 100, which will make 40,123 divided by 100, which makes 400, right? Okay, and this is correct. If you instead write like this, as some of you did, well, from a, let's say, human point of view, it's better because you underline the fact that this one, it's after all 20%. But for Solidity, it's completely different because what will Solidity do? 2000 by 20 divided by 100, which makes 2000 by 0. 20 divided by 100 makes 0.2, which in any other programming language is 0.2. In Solidity, it's 0, which makes 0. This is a severe mistake, I consider, because I underline it. Pay attention, first all the multiplication and only after the divisions, because divisions are pretty dangerous. It's better to do division with big numbers, so you don't drop too many decimal digits, because any division that you do usually drops decimal digits. If you put a parenthesis, you do the division immediately. Even worse if you write something like this. Number divided by 100 by amount. This is even worse. It's the same thing. You get 0. And also in this, there is another way in which you get 0. for example, P equal number divided by 100, and then P by amount. Okay, in this way you also get 0 because number divided by 100 is 0. Unless number is 100, in that case it's 1. Okay, so pay attention, divisions are always the last thing you do. Okay. Another little mistake that I found, it's whenever you have to make two payments in the same function. This is a little tricky. Usually it's a function which gives money out to other people. Usually what happens, you have a percentage and you give a percentage to a person and all the rest to another person. So let's make an example here. It doesn't need to be payable. You have a percentage, let's call it pairs. Okay. There is a specific example in one of my contracts. I think it's a purchase contract. So I was not very happy. I was not happy at all when people did this mistake. So what is the idea here? The idea is that you want to give to A, let's say, amount by percentage divided by 100, and all the rest we want to give it to B. So you int give to B equal amount by 1 minus pairs divided by 100. And then you do A transfer give to A semicolon, or here also the semicolon, and B dot transfer give to B. Okay, this one works fine and it's the cleanest way. Okay, there are other alternatives. I will write all of them in sequence here. Another alternative is here, address this dot balance minus B. This obviously works in case amount, it's the total amount which must be given. Let me replace amount with address this balance. So imagine we have to give away the entire content of the smart contract. This one also works. So you go, but this two works. Let's see what does instead not work. Instead of using the extra variable, I here put this thing, and here I put this thing. Or even I take the first example. And okay, this one doesn't work. Why? And I explain. The next person who tells me that the Mac is a good computer, my Mac is exploding. Okay. This one doesn't work. Why? Well, because as soon as you execute this one, address this balance changes. And so to address this balance that you use here, it's not the previous one. Okay? Here it worked because you first calculate the two quantities using address this balance, which does not change, and then you transfer. Here, as soon as you transfer the first quantity, address this balance, it's equivalent. Imagine you have 100 euro in your pocket and you say, we give 20% to this person and the rest to the other. So you give 20% to the person, and then you say, I now have 80 euros in my pocket. I give the rest, which is 80%, to the other. So 80 by 80, 64. So I give only 64. And the other 16 euros remain in your pocket. Okay. Try to do it in real life, and you will see whether the second person is happy. So this one doesn't work because as soon as you execute this instruction, address this balance changes, and this instruction doesn't work anymore. It works if you instead do something like this. In this case it works. So you give a part of your balance to the first person, and everything that remains to the second one. So pay attention, because this was an error I pointed out in the course. Okay, other little errors. Return the meaning of return. Sometimes a function must return. In this case, you have to specify here. Returns, for example, returns a string. Okay. In this case, pay attention, because if you write return and then ciao ciao, it's a string. Okay. As soon as you write return, the function ends. So everything that you write after, for example, price equal purse, okay, everything that you write after will not be executed. In this specific midterm, I did not consider this an error, even though it's a severe error, but didn't consider it to be an error because it's something which I didn't point out in class, and people who don't have programming experience with programming cannot figure it out easily. But pay attention, because as the return must be, and with a semicolon possibly, must be the very last thing you have in your function. Because as soon as the function finds the return, fine, it's done. So it's okay, doesn't do the rest. Okay, so don't put returns in the middle of the function. And finally, the last mistake, it's a mistake which I always point out in any time I have this course, because it's very famous. Pay doesn't need to be payable. Suppose you have to pay somebody, and you have at the same time to update the accounting system. So, for example, a supply to inform us that the person has been paid, or the balance. Typically, balances of message.sender, let's call this queue, balance message sender equal balances message.sender minus q, and then payable message.sender dot transfer q. Okay, this is the right order. First, update the accounting system, and then pay the person. Never do the reverse order. It's very dangerous. If there is a typical attack to a smart contract which calls the same function several times in a row, and the function is executed at the same time several times, and since the execution is line by line, if you invert the two lines, so you put this one first and this one later, it means that the person will be paid several times, and only later will his balance be updated. And this means that the person this way can withdraw much more money than what he has. Okay, so there is a require here. There is a require that the balance be enough. Okay, since this function are executed line by line, you hit a require, it's fine, you pay, then at the same time the person calls the function again before this one is executed, and so require is fine, pay, require is fine again, pay. There have been some attacks like this, and they worked. So please, first update the accounting system, and then pay. Okay. Always, I consider it a mistake if you do it vice versa. But sometimes it could be tricky because you have a lot of things to do. But remember, just put all the payment as the last thing the function does. So last thing the function does is all the payments. Okay, because it's very dangerous. You will notice, if you will go work in a bank, you will notice that all the people who are in direct contact with the public, before handing the cash, always update the accounting system before. If the accounting system goes down, they've given out the cash and goodbye. Okay, this was the list of mistakes, the most common mistakes, or basically all the mistakes that I find. Hoping that you will never do them again, or at least strongly reduce the amount. Bye bye.